Hi, this is Stan Lyle with Master Math. During the lesson, you're going to come to some You Try It slides where you're asked to do problems that relate to the lesson. Hit your pause button, try the problem, and then hit the forward key to move on to the answer. I hope you have a really good time today.
Today we're going to talk about compound inequalities. And the word compound just means to put together, to combine. So we're going to combine several inequalities to create one compound inequality. Now there's a couple of ways we can combine the inequalities. We can combine them with and, or we can combine them with or. Let's look at an example, and I think you'll understand what we're talking about. Let's say we want to buy tickets to the zoo. And prices for tickets are per this price schedule. If you're 0 to 5 years old, it's free. 6 to 11 years old, and it costs you $6 for a ticket. 12 to 55, the tickets are $10. And if you're 56 years or older, the tickets are free. Now, we're going to call X the age of the person. And we're going to try to create some inequalities that describe different portions of this ticket scheme. For instance, for the $6 tickets, I can see that I get $6 tickets if I'm 6 years old, but I don't get them if I'm 5 years old. So I've got to be older than 5. I've got to be 6 years old or older to get the $6 ticket. So I could write that as X, the age, is greater than or equal to 6. But that wouldn't completely describe the ages that that allowed me to get the $6 ticket. Once I got older than 11, the price went up to $10. So I'd also have to have X is less than or equal to 11. Between 6 and 11, I get a $6 ticket. And that's really combining two inequalities with the word and. If my age is greater than or equal to 6, and also less than or equal to 11, I get a $6 ticket. Well, how about a free ticket? Well, I can see that if I'm 5 years old or younger, I get a free ticket. So I could write that this way. If my age is less than or equal to 5, I get a free ticket. But I also get a free ticket if my age is 56 years or older. So if X is greater than or equal to 56, I also get a ticket. Now, I can't combine those with an and because my age can't be less than 5 and at the same time greater than 56. But I can combine them with an or. And that's the situation here. I get a free ticket if my age is less than 5 or equal to 5, or if my age is greater than or equal to 56. Let's talk about how we graph a compound inequality on a number line. You know how to graph simple inequalities. If X is greater than 32, you'd draw a circle at 32 because you wouldn't fill in the circle because the X is greater than 32 doesn't include 32. And then you draw a line to the right where the larger numbers are. So X was all the numbers to the right of 32. And you know how to draw this. 80 is greater than or equal to X. That's just another way of saying X is less than or equal to 80. So I draw a circle on 80, and I would color it in because 80 is included. I've got an equal sign there. I want to include the 80. But X is less than 80, so I draw an arrow to the left indicating that all the values to the left are smaller than 80 were included in 80 is greater than or equal to X. Well, what if I wanted to combine these two inequalities? What if I wanted it to read X is greater than 32, but also less than or equal to 80? How would I write that? Well, I can see I've got an X here, and to the left of the X I've got 80 is greater than or equal to, and I got an X here, And to the right of the x I've got is larger than 32. If I were to bring those two x's together and write 80 is greater than or equal to x, which is also greater than 32, I would have combined that inequality with that inequality into one combined inequality. And this is showing me that x is between 80 and 32. X is less than or equal to 80, and it's larger than or equal to 32. Now, how would I graph that on a number line? Well, I can see on the number line where I've graphed the two individual inequalities that the number 25 right out here works for 80 is larger than or equal to x, but it doesn't work for x is larger than 32 because 25 is not larger than 32. And I can see that that's because that 25 is to the left of my circle, which marks the end limits of my first inequality. X is larger than 32. I can also see that 90, while it will work for x is larger than 32, 90 is larger than 32, it won't work for 80 is larger than or equal to x, because 80 is not larger than or equal to 90. So this section out at the extreme right also doesn't work for the combined compound inequality 80 is larger than or equal to x, which is larger than 32. What we've seen is the area to the right of one extreme and the area to the left of the other extreme don't work for both inequalities. So if I want to graph the combined or the compound inequality, I want to draw a graph that only goes to those two extremes. And that's what the graph of 80 is larger than or equal to x, which is larger than 32, would look like.
Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer.
All real numbers that are less than 8 and more than minus 3. Well, I can see two inequalities in there. I see all real numbers that are less than 8, and I see a second inequality, all real numbers that are more than minus 3. So we're going to combine these two inequalities to create a compound inequality, and we're combining them with an and. That means that to satisfy the compound inequality, my number x is going to both be less than 8 and also more than minus 3. I've got to satisfy both inequalities. Well, let's see if we can write this. First, I see that x is less than 8. So x is less than 8. Then I see x is more than minus 3. X is greater than minus 3. Well, now x is less than 8. I can turn that around. I can rewrite that as as 8 is greater than x. And I want to do that because I want my x's in the middle. I want to be able to combine my two x's so that my expression reads 8 is greater than x, which is greater than minus 3. That's my compound inequality. X is between 8 and minus 3. It's less than 8, but it's greater than minus 3. Now let's graph it. I need a number line, and first I need to plot each of those extremes. One extreme is minus 3, so I'll draw a circle around minus 3. And I didn't fill in the circle because this is not x is greater than or equal to minus 3. It's x is greater than minus 3. So I don't want to paint over that minus 3 and include it. Now I need to put a circle around 8, and again I don't fill it in. And my x values are any values between those two extremes. So I'm going to draw a line between minus 3 and 8. And that is the graph for the compound inequality 8 is greater than x, which is greater than minus 3. Let's try another one. You know how to graph x is greater than 32. You also know how to graph 20 is greater than or equal to x. Well, you've just graphed the combined inequality. X is greater than 32, or 20 is greater than or equal to x. Compound inequalities that are combined with an or are just written exactly that way. Two separate inequalities separated by an or, by the word or, and the two inequalities are each drawn independently of each other. You try this one. Hit your pause button, try the problem, and then hit your forward key to move on to my answer. Yeah, I can be kind of picky. I'm just not comfortable when it's cooler than 55 degrees. And if it gets warmer than 90, I'm just too hot. So I'm just kind of picky. But I can write this down as a mathematical expression. And I can see that it says that the temperature is uncomfortable for me when it is cooler than 55 degrees or warmer than 90 degrees. So I'm combining two inequalities with an or. That means that I'll write two separate inequalities and separate them with an or. I'm going to call x the uncomfortable temperature. And then I'm going to say that x is less than 55. When the temperature is less than 55, I'm uncomfortable. I can also say that x is greater than 90, because when the temperature is more than 90, I'm uncomfortable. And if I wanted to write this, I just put an or between them, and it would read x is less than 55 or x is greater than 90. Now to graph this, I just graph each of these inequalities separately. X is less than 55. Well, I put a circle at 55. I don't color it in. And I want all the numbers that are less than that. So I'm going to draw an arrow to the left. My other extreme, or my other inequality, is x is greater than 90. So I'll draw a circle at 90, and I'll draw an arrow to the right towards the larger numbers. Well, hopefully you see that graphing compound inequalities isn't that tricky. And you're about to discover that solving compound inequalities isn't that tricky either. Let's say you were asked to solve this compound inequality. 12 is greater than x minus 3, which is greater than 5. And you can see it needs to be solved because what I want is just a simple x between my two inequality signs. I don't want x minus 3. I want x is less than something and larger than something. I need to get rid of that minus 3. Well, how am I going to do that? Well, first, let's remember that this is a compound inequality. I've combined two separate inequalities. My first inequality is 12 is greater than x minus 3. My second inequality is x minus 3 is greater than 5. So I've got two inequalities, and I could solve them each separately and then recombine them. I have 12 is greater than x minus 3, and I have x minus 3 is greater than 5. Let's do the top one first. 12 is greater than x minus 3. I want to get rid of that minus 3. In order to get rid of that minus 3, I need to add 3 to both sides of the equation. Now I simplify, and I get 15 is greater than x. Now let's try the second inequality. X minus 3 is greater than 5. In order to solve that, I again need to get rid of minus 3, so I've got to add 3 to both sides of the inequality. Then I need to simplify that inequality, and it will read x is greater than 8. Well, now I know that 15 is greater than x, and x is greater than 8. So I know that x is between 15 and 8. And I can write it this way. 15 is larger than x, which is larger than 8. And if I were to graph it, I'd put a circle at 15 and a circle at 8, which are my two extremes, and I draw a line between them, indicating that x was between 15 and 8. Here's a compound inequality that's separated with an OR. So x can either satisfy the left or the right inequality. It doesn't have to satisfy both. Well, how would I solve this for x? It's really easy. I just solve each of the two inequalities independently and then bring them back together again. Let's start with 2x is less than or equal to 4. To solve that, I need to divide both sides of the inequality by 2 in order to isolate my x. 2x divided by 2 then is less than or equal to 4 divided by 2. And I can simplify that to x is less than or equal to 2. My other expression was 3x plus 1 is greater than 13. That's a two-step solution. First, I want to get rid of that plus 1. So I'm going to subtract 1 from both sides of the inequality. Then I simplify, and I've got 3x is larger than 12. Now I need to get rid of the 3. So I'll divide both sides of the inequality by 3. And then I'll simplify, and x is greater than 4. So my combined inequality is x is less than or equal to 2, or x is greater than 4. And if I were to graph that, I'd just graph each of those inequalities separately. X is greater than 4, and x is less than or equal to 2. Try this one. Be careful how you deal with the negative variable. Hit your pause button, try the problem, and then hit your forward key to move on to my solution. Okay, this is a compound inequality, and I can see two inequalities. I can see that minus 5 is less than 5 minus x, and I can also see that 5 minus x is less than 16. So I want to solve each of those inequalities separately. I need to isolate the x, get rid of the 5, and get rid of that minus sign. Let's try the left side first. Minus 5 is less than 5 minus x. Well, I got to get rid of that 5 that's on the side of the inequality with the x. I got to get rid of that 5. To get rid of that positive 5, I need to subtract 5 from both sides of the inequality. Then when I simplify that, I've got minus 10 is less than minus x. Now to get rid of that minus x, and it's helpful to remember that that's minus 1x. It's minus 1 multiplied times x. To get rid of that minus 1, I need to divide both sides of the equation by minus 1. So I've got minus 10 divided by minus 1 is less than minus x divided by minus 1. When I simplify that, I get x is not less, I get 10 is not less than x. I get 10 is greater than x. Because I divided by a negative number, I got to reverse my inequality sign. How about the other side? The other side of the equation, or the inequality, read 5 minus x was less than 16. Again, I need to get rid of that 5 that's on the side of the inequality that x is on, so I'm going to subtract 5 from both sides of the inequality. When I simplify that, I get minus x is less than 11. Now, I got to get rid of that minus sign, so I got to divide both the left and the right side of the inequality by minus 1. Minus x divided by minus 1 is less than 11 divided by minus 1. When I simplify that, I get x is not less than, x is greater than minus 11. I divided by a negative number, so I've got to reverse my inequality sign. Well, now I've got 10 is greater than x, and x is greater than minus 11. If I just bring those two x's together, I can rewrite this as 10 is greater than x, which is greater than minus 11. And to graph it, I need to define my two extremes. One of my extremes is minus 11. And it's a circle because it's greater than minus 11. It doesn't include minus 11. My other extreme is 10. And again, it doesn't include 10. It's x is less than 10. And x is all the numbers between those two extremes. So I'll draw a line between those two circles, and that'll represent the inequality 10 is greater than x, which is greater than minus 11. That's our lesson on solving and graphing compound inequalities. I hope you understand the concept pretty well. Why don't you test your skills? Go to www.mastermath.info and you'll find there some worksheets and some quizzes on solving and graphing compound inequalities. Well, I hope you had a good time, and I hope we see you again real soon.